So let us start with the tutorial. So there's the PDF. I can open the file and show you the other. This is the file that I followed. So you can find in archive refinement types tutorial, which I'm not sure it's the best title, so I think a better name would be liquid types, and I will be discussing that in a minute. So I don't think we'll even get to chapter 5 today. Just prepare everything so next time we can do either chapter 3 or chapter 3 and 4. So we are going to start with this refinement logic first. But before that, let me show you a little bit of a refinement type. So you could say that a of type integer is 1. Okay, and this is a regular type, there's nothing special about it. But you can say, and this is my preferred syntax, you can say that the type of a, it's an integer such as that integer. So I'm saying x, which is the name that I gave this this type, equals 1. Okay, and this is a very precise type of what variable a is. But I could have something like greater than 0, which is also a valid type for a, because 1 is greater than 0. And you can build all sort of expressions that would be valid and true. Okay, so all of this is is correct in the sense that this type represents the value that is there. We can also have something that doesn't type check. So we're saying that the type of a, it's an integer that's different than 1, but that's clearly not true. So this should be a type error, and your compiler or your editor should complain. You can also say something like greater than 2, which is also incorrect. Okay, so as you can say, you can express several properties about this type here, calling the value x, or as in the default name, it's v in the tutorial, which I believe stands for value. Okay. In the tutorial, they call it integer v such that v greater than 2. So they use a syntax is a little bit different. In most of the papers I see, I usually find this notation, which is the one I'm going to use, but you can also use or something like this if you prefer, or in some other languages it's something like, I think in Lean you have something like this, where you can talk about, or you can even have a lambda x and some property of x. Okay, and the x will be the value of integer. So you have several syntaxes that people use to describe refinement types. Okay, so first question. So I'm seeing the questions with a bit of delay. So Z3. Z3, it's its own theorems. It's not well, it's a theorem solver, but it's more like an automated tool that accepts SMT encoding and translates it to set, and it then Z3 is a set solver. I'm going to show you that in a little bit. Okay. Okay, I think there's an issue with the stream that I'm probably streaming with very, very high definition, which is clearly not.